Hello everyone. In this video I am going to explain some of the uh, specific cases for Pn of x. That is, Pn of x is what? Legendre's function. So special functions, among them Legendre function is one of the important special function. So in that, once you derive the solution for the Legendre's differential equation, you will get the solution in terms of Legendre's first kind and second kind. So first kind is given by Pn of x. So what are the specific cases of Pn of x? Let us discuss here. So Pn of x, if you take, that is Legendre's function. P naught of x equal to 1 we have to prove. So P naught of x is equal to 1. In place of n, value of n is equal to 0. That is P naught of x equal to 1 we have to prove. So let us take the Legendre's function. Pn of x is given by summation r equal to 0 to n minus 1 to the power r 2n minus 2r factorial 2 to the power n r factorial n minus 2r factorial n minus r factorial x to the power n minus 2r. So this is the Legendre's function. We have to put n equal to 0 and r equal to 0 in the above equation. We will get P n of x is what? P naught of x. So this is the equation we will get after substitution. So all values will become 1. Okay, then the answer will be 1. So P naught of x is equal to 1. This is how we can prove. If you take P1 of x, that is equal to x, like that n equal to 1, 2, 3, so on, you can substitute the values and you can calculate the Legendre's function. 1, 2 and so on. So here P1 of x is equal to x, P2 of x is equal to 1 by 2 into 3x square minus 1. So next one, Pn of 1 equal to 1. How we can prove it? By taking generating function 1 minus 2xt plus t square to the power minus 1 by 2, that is equal to summation Pn of x t to the power n. So here 1 minus 2xt plus t square to the power minus 1 by 2 is equal to what? Generating function of Legendre's function is equal to summation Pn of x equal to what you have to take? 1. So x equal to what we have to take? 1. Okay. Then Pn of 1 into t to the power n we have to write. If you put x equal to 1, this generating function will become 1 minus t to the power minus 1. Pn of 1 t to the power n. So if we write this equation in terms of power series, that is equal to summation m equal to 0 to infinity t to the power m. Then that is equal to summation Pn of 1 t to the power n. Comparing the coefficient of t to the power n, m here on two sides of the equation. So t to the power m coefficient is 1. Okay, and here t to the power n coefficient is Pn of 1. So Pn of 1 is equal to what? 1. By using generating function we can prove this special case. So next let us go for third one. Pn of minus 1 equal to minus 1 to the power n. Again we can use the generating function here. In case of x equal to 1 we have taken here x equal to minus 1 we have to take. Once we substitute x equal to minus 1, this LHS side of the generating function will be written as after simplification 1 plus t to the power minus 1. Earlier 1 minus t to the power minus 1 we got, here 1 plus t to the power minus 1. So RHS said Pn of minus 1 to the power t to the power n. In terms of power series, we can write it as minus t to the power m equal to summation Pn of minus 1 t to the power n. If we equate the coefficient of t to the power n on two sides of the equation, we will get Pn of minus 1 equal to minus 1 to the power n. This is the solution. Third specific case. So next one, fourth one, Pn of minus x minus 1 to the power n is into Pn of x. We have to prove. So Pn of minus x is what? Minus 1 to the power n Pn of x. Again generating function we have to use. Then generating function for Legendre's function, that is equal to summation Pn of x t to the power n. On changing x by minus x, here whatever the x is there, we have to change it by minus x. T by minus t in the equation, we get 1 minus 2xt plus t square to the power minus half Pn of minus x t minus t to the power n. Substituting equation, we will get summation Pn of x t to the power n is equal to summation Pn of minus x minus t to the power n. So this we can do like this. Minus 1 to the power n we can take common and t to the power n we can write. We should equate the coefficients of t to the power n on two sides. We will get Pn of LHS side Pn of x coefficient of t to the power n, and on RHS side coefficient of t to the power n is minus 1 to the power n Pn of minus x. So this is the final result. We will get Pn of minus x is equal to minus 1 to the power n Pn of x. So like that you have to solve the specific cases for Legendre's function. I hope it is useful for you. Thank you.